Hello everyone, welcome to this lecture on the pumping lemma. Today we will delve into the pumping lemma for regular languages. This is a core concept in the theory of computation. So, what exactly is the pumping lemma? It is a mathematical tool that is used to prove that certain languages are not regular. In other words, it helps us demonstrate that some languages cannot be recognized by finite automata. Here is the formal statement of the pumping lemma. If L is a regular language, then there exists a positive integer p, which is the pumping length, such that every string s belonging to L with the length of s greater than or equal to p can be divided into three parts, s equals x, y, and z. These parts must satisfy the following conditions. The length of x concatenated with y is less than or equal to p, the length of y is greater than or equal to 1, and x, y raised to the power of I and z is an element of L for all I greater than or equal to 0. Let's visualize how a string s is divided according to the pumping lemma. We have three parts, x, y, and z. X is the prefix, y is the pumpable part, and z is the suffix. The entire string s can be represented as x, y, z, where the length of s is greater than or equal to p. The idea behind the proof of the pumping lemma is based on the fact that for a regular language recognized by a finite automaton, long strings must cause state repetition. This is due to the pigeonhole principle. The key insight here is that repeated states create loops that can be pumped. Here are the steps to use the pumping lemma to prove that a language is not regular. First, assume that the language L is regular. Second, choose a string s belonging to L such that the length of s is greater than or equal to p. Third, show that no valid x, y, z division exists that satisfies the conditions of the pumping lemma. Finally, conclude that L is not regular if a contradiction is found. Let's consider an example to illustrate the application of the pumping lemma. Suppose we have a language L defined as the set of all strings with a raised to the power of n concatenated with b raised to the power of n, where n is greater than or equal to 0. This language consists of strings with an equal number of a's followed by b's. Examples of strings in this language include epsilon, a b, a v, and so on. In summary, the pumping lemma is a powerful tool to prove that languages are not regular. It does so by demonstrating contradictions in string decomposition. Thank you for your attention. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.